Festival, which was published this year for the management of COVID-19. Now, before now, we have talked often about evidence is not really in the textbook. We have to look at journals and then make up our minds whether or not we're able to use this evidence that we find in our domain. Now, we're just going to be looking at how you critically appraise a document and then see for sure whether or not we can actually appraise this article for use by us. Okay, so first things first, how do we even begin to look at the evidence? Okay, how do we apply evidence-based practice to what we do? Now, there are 4 basic steps in doing that. So for every article or for every issue I want to address, I need to first find out, one, is there an answerable question here in this article? Okay, that's what we all have been trying to do over time. Even when we are running our own personal research, you want to do your research for MEd, you want to do any publication, you always want to start from the basics. What is the question being asked? So that you have an idea of where you're going and what answers are available for you. Then the second thing you want to do is to track down the best evidence. About 2 or 3 weeks ago, Dr. Kabambi did a presentation on the evidence available out there. So what did he do? I'm not going to go over that again. He basically went in search of the articles that are available there and then stratified them according to the levels of evidence. Now, a quick reminder about the level of evidence. You would read in certain journals and you will find it say, oh, this is a level 1 evidence, this is a level 2 evidence, this is a level 3 evidence. Evidence are graded on levels based on, 1, how appropriate the methodology is to answer the question in that circumstance. In other words, if I was doing a study on the effect of something dangerous on humans, the best I can do is to observe those humans who have done those dangerous things. So it will be an observational study. So that study becomes like a level 1 in that category of harm. But say I was looking at an intervention, remdesivir versus any other drug A or drug B in the management of COVID, then the gold standard would be to do a randomized clinical trials, okay? So that becomes either a level 1 or a level 2. Now, what makes it a level 1 or a level 2? If there were systematic review, or if there were many more primary studies looking at that particular issue at the same time, then a systematic review of those randomized clinical trial is said to be at a higher level. So that becomes a level 1, and then your primary studies becomes a level 2. That's just an idea of how these levels are graded. Now, when we stratify these levels and we see those evidence, we can begin to read them and critically appraise them, okay, before trying to apply them. So for today's presentation, we're just going to go straight and delve into points 3 to 4, because for point 1 and 2, we have similarly dealt with it at other levels. Now, I get a paper like the one we have now. We now want to critically appraise that evidence. So that's step 3. If we critically appraise the evidence, is the same, to critically appraise an evidence is the same thing as carrying out an internal validity, which is in bracket, of the study. Now, what does this actually mean? It means that we're trying to look at whether or not the study was rigorous enough to allow us decide whether or not the conclusions that were reached in that paper are good enough for us to apply. 2, if the study is sufficiently valid, if the conclusions are good enough, if the method is rigorous enough to give us that conclusion which we have reached. Remdesivir is very effective in the management of COVID, for example. How do we begin to interpret the results that were in that studies to make sure that that conclusion that was drawn in the first place is actually correct? Now, this used to be a horrendous task because nobody actually knew, only very few people handed it down from persons to persons until the development of evidence-based medicine as a subject on its own, which actually started from clinical epidemiology and later became evidence-based medicine. So that's what we're going to be dealing with today. And then, of course, the step 4 is applying this evidence, okay, to our own practice. In other words, in our own setup at the hospital here. Now, that is what we refer to as external validity, or the generalizability of the article. Can the conclusions reached by this author be generalized to me? For you to be able to answer that question, you would have to look at the results and find out whether or not it will help you in managing your patients. 2, is the treatment that is being purported, is it feasible in my own setting? If the treatment for COVID now is ECMO everywhere, we don't have an ECMO here. Can we afford one? Can we install it here? Can we make it functional? Those are the things you will now start looking at. Then 3, is my patient or the patient population I'm going to be dealing with, are they exactly different from the population the people had studied? If the study of Remdesivir, for example, was done in a pediatric group, would it be appropriate for me to apply it, therefore, if I am an internal medicine physician in internal medicine for adult patients? Will I get the same results? Would they apply? Those are issues you deal with in external validity. Now, with the potential benefits of treatment outweigh the potential harm of the treatment for my patients. So you look at the risk profile of the drug. So that's what basically we will look at in the paper that was circulated, and then we can then say whether or not we may need to apply this. However, because people have been studying this over time, there are some basic questions, 1, 2, and 3. If I get here is a no, 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 then that paper is really not worth reading. With all due respect to the publishers and to the authors of such a paper, because I know it takes hard work and takes a lot of pain to get a paper published. But anyway, everything I have mentioned or have tried to describe so far is not far-fetched. Get the hang of it. Visit Critical Appraisal Skills Program, CASP, at the website you can see, or Center for Evidence-Based Medicine. And you will begin to find out that, or you begin to see what kind of tools that you can use to help you appraise any kind of research method or paper that has been published. So the point being, if I assess, or if we assess this randomized controlled trial the way we are going to this morning, can I apply it to a cohort study? No, because the methods are different and what you are looking for are different. So at the end of today's presentation, we're not going to become experts in analyzing all papers. It's going to take time and it's going to take a build-up. So we have to be what? Patient with it, and we have to keep studying it. But for today, because our article is on randomized controlled trials, we're going to be looking at those important things that make up a good internally valid paper. In other words, that gives randomized controlled trial its name and why it's the gold standard. So, critical appraisal of remdesivir in adults with COVID-19. A randomized, double-blind, placebo-controlled, multi-center trial by Yemin Wang et al. 2020. Now, this author has told us what they have done in their title. You can find this in many other titles, in so many publications as well. But the question is, did they actually do what they said they were going to do? Is it actually all within the paper? And that's what critically looking at it is all about. Okay, so what are the critical questions here? One, are the results of this study valid? What are the results if they are valid? Will the results help me? How big are these effects? So let's try and take a look at that paper and see. If you look at that paper, you would find out that, by the way, I'm using the evidence-based medicine critical appraisal tool for randomized control trial. That's what I've used in this presentation. You can also use the CSAP. I've chosen this because it tries to help the reader to look for those things and tells the reader where to actually find the whole thing. Can I project the tool? Okay, you got it. Can you project the tool? Okay. Yeah, I just wanted to project it there. Okay, now if we look at the tool, please, I beg your pardon, I'm going to be jumping from this tool back to my presentation, and it may take a bit of Now, if you look at the tool, you'll find out that the first question you want to ask is, are the results of the trial valid? Okay, if the results are not valid at all, then there's no need even considering applying it to anybody for that matter. And the first question that is asked there is, what question did the study ask? Okay, did the study ask a question that was actually answerable by a randomized control trial? Okay, then the follow-up question is, if the study actually complies with an answerable question for randomized control trial, was the assignment of patient to treatment randomized? Because that's where the study gets its name. It's a randomized control trial. So you want to find out, was there randomization? Okay, and here it is expected that you answer yes, there was randomization, no, there was no randomization, or it is unclear. Okay, then you go to 1B. If there was randomization, were the groups similar at the start of the trial? Okay, here the best or the ideal thing is that after randomization, the baseline characteristics of everyone in that trial in both arms should be similar. May not be exactly the same, but should be very closely similar. Okay? Now, where do if you look at this other, at the right-hand column, you'll find where the author tells you where you can actually find this. The results or the paper should have a table or should be well explained in the results section, a table of baseline characteristics. So most journals will ask you for a table of baseline characteristics of your participants, in the study. So you can either find them at the results section or you can find them at the beginning of methodology of the method section. And then you're also supposed to answer whether or not there was similarity or there was no similarity or it's unclear. Okay, then question 2, aside from the allocated treatment, were groups treated equally? In other words, for randomized control trial to be of benefit, both groups must be treated similarly, such that the only difference between the experimental group, which is the remdesivir group, and the placebo group would just be remdesivir. That is the only thing that would help you at the end of the day in your conclusion. If there is actually a difference, then you can begin to point that since that was the only different thing I did in this group and I'm getting these results, then it is likely that remdesivir is the one giving us the difference we are experiencing in both groups. Okay, so you also answer whether or not it is yes, it is no, or it is unclear. B, were all the patients who entered the trial accounted for? Now, this is of great statistical issues. And you begin to find out that a lot of papers would try to avoid this because I can collect my data and I can manipulate my statistics to show the result I want the statistics to show. So because of that, the gold standard for accounting for patients is that all participants in the study, whether they drop out, whether they die, whether they discontinue, must be accounted for at the end of the day, okay? Now, loss to follow-up should be minimal. It's preferred, less than 20% for a randomized control trial. If your patients have outcome of interest, then even a smaller loss can only be tolerated. Now, patients should also be analyzed in the group to which they were randomized to, which means under this section, you need to specifically look for intention to treat analysis being done. Now, what is intention to treat analysis? It simply means that once you have randomized and allocated a patient to either group, that patient must continue in that group or be analyzed in that group at the end of the research, irrespective of where the patient eventually ended up during the process. In other words, if a participant was analyzed for remdesivir and for some reason had serious side effects and had to be discontinued, that patient should still be analyzed under remdesivir. If the patient says, no, I do not want to continue anymore, the patient will still be analyzed under what? Remdesivir. So that's what intention to treat analysis means. And that gives you kind of the best results, so to say. But if you're not able to do that, people will then look at per protocol analysis. Should there be a crossover? In other words, if a participant moves from treatment group to the other group or vice versa. Now, at the end of the day, you're going to answer whether or not there was intention to treat analysis, whether or not it was done, and whether or not the loss to follow-up was huge, such that the baseline characteristics can become altered, okay? 3, were the measures objective, or were the patients and clinicians blinded, to the treatment being received? This is taking care of blinding, okay? Was the allocation concealed, and were they blinded to the treatments that were being given? In other words, they will not be able to bias the study, because if I know that I'm getting this, my nursing, if I'm getting those in the remdesivir group and I'm prone to that, the nursing management can improve there. I can do ward rounds 5 times for that patient on remdesivir just because I want to make sure I catch anything early, correct it early, and have a better outcome later. So if the patients were all blinded, then you are likely to treat every patient equally, okay? And then we will answer the same questions. It is only after we have dealt with this and we find out that it is okay, yes, 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 all through, then your results will be worth looking at. If there's so much bias in this first phase of the question, in fact, the first 3 questions would tell you whether or not you may need to continue with reading that paper in itself, okay? Now, the second aspect is now looking at the results and seeing the magnitude or the size of the results. And the way we look at the results are basically in two ways. One, how large was the treatment effect? We want to see the magnitude of the treatment effect. Was there really a difference? Was this difference really huge? Now, in dealing with this aspect of the results, please bear in mind that your results can come most of the time primarily in two forms. One is a dichotomous value, which means yes or a no. Did the patient die? Yes or no. That you can't hide. It's very objective. The patient is dead, is dead. Everyone knows the patient is dead. You certify. No queries. Is there fever? There's a cutoff for temperature. Is either fever above 37.1 or below 37? You know, dichotomous. When there are dichotomous values, then you would expect that the presentation of your results can come in any of the forms you see on that paper that has been sent to you, either as relative risk, which is the risk of outcome in the treatment group, divided by the risk of outcome in the control group, okay? And it just tells us the probability or the chances of, in this case, remdesivir. If I use it and the patient improves, then it tells me that the relative risk of either getting worse will be reduced or the risk of improvement would increase. Now, its interpretation, I'll get to it shortly. Another parameter that can be looked at that authors and statisticians will provide are absolute risk. Now, because I'm using the word risk now, let's use a simpler example that would synchronize with you. Let's take death, for example. If I say we're taking remdesivir to prevent death, right? In other words, if I take it, I expect that the death rate in the treatment group taking it should be reducing. And that in the control group would move through its natural course. An absolute risk is when we actually subtract the risk in the control group minus the risk in the treatment group to get that absolute difference, okay? Now, why do we need it? Why do we need this absolute difference? The absolute difference kind of tells us the rate of the event happening, how fast people are dying in this group because they are not using remdesivir versus how fast they are getting better in the other, dying in the other group, okay? Now, how do we interpret these two values? Because the relative risk, RR, is a division sign, okay? Is risk of outcome in the treatment group divided by risk of outcome in the control group. If I divide 10 by 10, it's what? 1. 5 by 5, it's 1. It therefore means that the point of no difference, because there are 5 in this group, there are 5 in the other group, is 1. So anytime I'm interpreting the relative risk, I'm looking at the relative risk, I'm going to be looking for the first things first, 1. If you tell me the RR is 1, then that tells me that in that study, there was no difference. So whatever you are investigating really doesn't mean anything much, okay? What if the relative risk is less than 1, okay? If the relative risk is less than 1, it means that the treatment is decreasing the risk of that expected outcome. In other words, if the relative risk is now calculated at 6.1 or 6 or 0.6, sorry, 0.6. 0.6 is less than 1. It means that if you are taking that drug, the people in that group have a 40% decrease in the chances of dying. Okay? It's not like 40% of that group will not die. No. We're looking at the risk now. It means that they have a 40% chance that they would not die. So we would expect a 40% recovery, so to speak, from that group. What if the relative group is the relative risk is greater than 1? If we're still talking about death, greater than 1 will mean that that drug is probably worsening the case and causing more people to what? To die. Okay? So let's bring that to our remdesivir. Note that in this case, they were looking for what? Improvement. We'll get to that. So in improvement, it kind of works almost in the opposite direction. So if I have anything greater than 1, it means many more people in the treatment group are getting better. And if I have less than 1, it means they're getting worse, okay? That's how it applies, okay? Absolute risk reduction, on the other hand, is a what? A minus sign difference. 1 minus 1, 0. 10 minus 10, 0. 5 minus 5, 0. In other words, if an absolute risk is reported, okay, absolute risk reduction is reported, I want to look for that 0 margin. So if my value they are reporting is a 0, it therefore means there's no difference between the two groups, okay? Because they have almost equal numbers, all right? So if therefore the subtraction yields a difference, then you can say the absolute difference can be quoted. But where do we use absolute risk reduction more? We use absolute risk reduction, especially when we want to calculate the number needed to treat. So if we say, therefore, that the absolute risk reduction, okay, is 0.5, for example, 1 divided by 0.5 would give us the number needed to treat. If it is 0.7, 1 divided by 0.7 will give us the number needed to treat to get a benefit for 1 person. So take, for example, remdesivir in this case. If the absolute risk reduction were to be 0.7, 1 divided by 0.7, that would be 10 over 7.
1.42.
1.42.
Mm,
okay, so it will be 1.42. So we can say 2. That means that drug is very good. Because if I treat 2 people, 1 person would benefit. When I treat 2 persons, 1 person will benefit. Okay? So as the absolute risk reduction varies, your number needed to treat also increases. The bigger the number needed to treat, then the more you want to query when you are applying this in stage 4 of your analysis. Okay? Now, whatever values we get, either in risk reduction, relative risk, or absolute risk, it comes with a confidence interval. Okay? What does that confidence interval mean? A confidence interval, okay, let's start from p-values. You're going to soon find that, or you will read articles that say a p-value of 0.05 is statistically significant. Yes, statistically significant means by statistics, but it does not really tell us anything clinically. Is it clinically relevant? The clinical relevance is often lost in that statistical significance. That's why most statisticians in clinical practice now deal with confidence interval. And what does confidence interval mean? The confidence interval tells you that if I have a value of, say, 2 with a confidence interval of 1 to 2, it's telling me that the true value of the true, okay, remdesivir was used in this treatment and it had a relative risk of 0.38, confidence interval of 0.28 to 0.45. It tells me that that risk we're seeing, even in the general population, if I apply remdesivir, everybody is going to fall within that bracket, 0.38%. The true value of the effect of remdesivir in the population will be between the confidence interval that has been given. So we're 95% sure that that relative risk reduction or improvement is actually worth it. But how do I interpret confidence interval, therefore? To interpret confidence interval, if we're dealing with relative risk, it takes us back to that issue. Does the confidence interval contain 1? If it does, then it is not statistically significant. Why is that? Because even the point of no value is within that confidence interval. If I'm dealing with absolute risk, if the confidence interval contains 0, then it is not statistically significant because we're dealing with a point of no difference, okay? Now, how wide or how narrow your confidence interval is what gives you how precise that study was in terms of getting the values that they say they are getting, okay? Now, before we start sleeping or get further confused, let's go back to our presentation and see how this applies to what we've been doing. Where's the slide? Okay, so the first question. What question did the study ask? In other words, did they follow the PICO rule? Participants, were they identified? Was the intervention clear? Was the comparison clear? Were the outcomes stated? Okay, so here, yes, the participants were adults greater than 18 years of age who were COVID-19 positive. They stated that, okay? Intervention they were trying out was remdesivir, and they were comparing with what they called what? Placebo. But now, outcome, clinical improvement. So clinical improvement was their primary outcome. Duration of illness and death were secondary outcome or were part of qualifying the primary outcomes. So they did cover that basis in asking the question, okay? What's happening to this slide? Okay. Okay. Now, the second question was the assignment of patients to the treatment randomized? That you can find on page 3 of the under the heading methods. Okay. So if you go to page 3 of that article, can you project the article? It was clearly, a section was clearly headed there, randomization and masking. Let's see if we can project that for you. Okay, under that section, it was said eligible patients were randomly assigned 2-to-1 ratio to either remdesivir group or the placebo group. That was on page 3. Okay, they further went ahead to say, don't worry if you can't find it, block stratified or block randomization was done. Now that block stratification was done using oxygen need parameter. One was for low oxygen need and the other one was for high oxygen need. Low oxygen need was nasal cannula, face mask. High oxygen need was high flow, non-invasive ventilation and ECMO. Okay. And the permutation was for 30 patients per block. In other words, they made sure they first divided the patients into these 2 groups before randomization, and then randomly assigned group A, which was low oxygen need, into the 2 groups. Group B, high oxygen need, into the 2 groups. Now, what did that achieve? That helped them to distribute patients who were severely ill equally into both groups, okay? Because they were randomized separately into both. So if you, at the end of the day, Each control group, which was the placebo group, would have low oxygen patients, patients needing low oxygen and patients needing high oxygen. The same thing would happen for patients needing high oxygen in the treatment arm, okay? Now, the other thing we're expected to look at, if you look at that article, is how was this randomization done? Was it by flipping a coin, or was it by using the computer-generated numbers? The gold standard is using computer-generated numbers. And here, that was what the authors did. They even gave us the version of the computer the statistician used, SAS software program, to randomly allocate. Now, in addition to that, the end of that paragraph also stated that the pharmacy, the central pharmacy in Jingyangtang Hospital was responsible for actually preparing the drugs, numbering them, and then distributing them. And that drug would include both the remdesivir and the placebo, okay, based on their sequence, random allocation sequences. And they were simply given to the patients who were randomly assigned to that number. So that made the investigator at the hospital blinded, the patient blinded, the nurses delivering the drug blinded, because all they would see is the same color of fluid, the same consistency, but just with a serial number, and they was expected to give based on the same prescription that was given for use, okay? And the prescriptions were defined there. So the question will be, at the end of the day, did they actually answer question A1? For me, I would say yes. For you, I don't know what people think, but I would say yes, they have answered that question. So we'll move to the next question. Were the groups similar at the start of the trial? Okay, for me, the answer was no here. And even the authors acknowledged the fact that it was a no here. Now, what were the major issues? This can be found on the table of baseline characteristics. I think the table of baseline characteristics is on page 3 or 4. Yeah, page 4. Table of baseline characteristics, page 4. Okay? Now, if you look at that, they can see this, right? Okay, maybe I should project it for the people that for. Just a minute, let me project this for the people. Yeah. Firstly, one, the numbers that were randomized were not the same. Okay? The randomized ratio were that of 2:1. Now the gold standard is for 1:1. Now why would people randomize 2:1? It was initially thought, initially thought that if you do a 2:1, you'll be able to get more people into the treatment arm on time so that your trial does not stay too long. But this has statistical implications, okay, which the authors have not catered for and which became the biggest drawback in this study. Because when you do a ratio of 1:1, the expected crude participant number, in other words, your sample size that you expect, is supposed to have at least 50 events in the control arm. What do I mean by that? If the event we are looking at, say deaths, the number of people that should be in the control arm should be large enough to account for at least 50 events. And that will now depend on the percentage that you are looking at, or the percentage of events that happens vis-a-vis the number of people in that group. So if your ratio increases to 2:1, the statistical implication is that your sample size must increase. And in fact, it's been calculated by statisticians that if your ratio moves from 1:1 to 2:1, you need to increase your sample size by at least 12 to 15% from baseline. If it moves to 3:1, Your sample size, therefore, must increase to as much as 33% in addition to the sample size at 1:1. In this study, they were not even able to achieve the desired sample size for a 1:1 and had to stop early. So in other words, they were far away from reaching the 1:2 sample size. And the implication of that, therefore, is that your study becomes less powered to actually find the difference you are looking for. So whether or not remdesivir is actually working, it becomes a very difficult issue because the power of that study is now way below 80%. In fact, in this study, they postulated that their power had dropped down to as much as 50 what percent? About 52 or 53% or 58%. I'm not so sure about that. Okay. Now, if your power drops that low, then whatever difference you are seeing may not necessarily be true. So for me, it was a no. Okay. Question 2A. Aside from the allocated treatment, were the groups treated equally? If you go to the table on page, let's look for the table. Okay. Treatment received before. Okay. Table 2, treatment received before and after. Let's see. You will find out that they received almost similar treatment. They received almost similar treatment as outside of, let me see if I can project that for you. That's page what?
5.
Okay, here we are. Okay, treatment received before and after. If you go through them, you'll find out that most of the things that were done here were actually done here, and their percentages were almost, okay, before and after, yes, were almost similar. Now, the other thing that was shouting here was the commencement of study. Okay, you will find out that early, those that started early, because they actually measured from time of symptoms to when they were recruited and got into the study. And then they found out that in the control arm, you see this 60% here, 60% of the people here started early as compared to 46% here. Now, what's the implication of that in our study? If we say coronavirus would peak at day 7, day 8, the effect will peak at day 7, day 8, and by day 14 is dwindling down already. It therefore means that many more people were already at the tail end or the clinical end of the syndrome before they were recruited into the treatment group. So whatever effect you are seeing, it's difficult to actually tell whether or not is this as a result of the natural cause of the disease, or is it because of the intervention that is actually being given? So that's a very huge question when it comes to that particular issue. Okay. However, we would say on the overall, just looking at the question themselves, yes, they had before and after the enrollment, they all had almost the same type of treatment afterwards. Question 2B, were all participants who entered into the trial accounted for, and were they analyzed in the group to which they were randomized? Well, almost all of them were accounted for. Okay, if you look at the flow chart that was given, you will find out that there was all the numbers tallied up from the top to the bottom, and those that were not there were fully explained. But they were not all analyzed according to intention to treat analysis, ITT, okay, or the intention to treat principle, which I've explained earlier on. That once a patient is randomized, he or she should be analyzed in the group they are randomized to, even if they never received that treatment. They discontinued the trial or they had crossed over to the other. So in that aspect, because of that, I would say no. Okay, were measures objective? Okay, or was there blinding? In fact, question 3M actually speaks to blinding in the trial, so that the provision, even if you say, okay, they all had the same treatment, but you and I know that when dealing with medicine, clinical services, it's all about empathy, personal relationship, how nice you are, can all influence how a patient responds to the treatment that you have. But were they blinded? Yes, eligible patients were allocated to receive, okay. Now, this can be found also on page 3, where it was stated that the eligible patients were allocated to receive medications. And these medications were individually numbered in packs and according to the sequence order in which the randomization center generated it by the hospital. So the envelopes were prepared for emergency unmasking, okay? Emergency unmasking, why would I need to unmask? Assuming a patient starts developing unusual symptoms, reaction that we don't know, we need to find out, was this patient on that remdesivir or was it placebo? We need to find out so that we know how to manage whatever, and that is where unmasking comes. So every randomized package comes with an envelope for unmasking, and that unmasking would only be done only when there is a problem or when there is a protocol violation. Okay, so yes, it was covered. Okay, so far we've had 2 no's and we've had 2 yeses. At this point, would you say the paper is worth continuing? Some people will still say, okay, well, it's difficult to just stop here. Let's see what they have. But at the back of our mind, we must bear that there's some element of bias already going on, even though it has been beautifully written. So what were the results, therefore? So now we have looked at the rigorous nature of how the study was carried out. We see that they have tried as much as possible to be very rigorous. They've only erred in their analysis protocol because they did not abide by that. Okay, so what were the results? Outcome measures. Okay, table 3. The results can be found in table 3. Okay? Outcomes in intention to treat population. That's the title of the table, table 3. Let's note. Now, this is where when you read a study like this, you need to remind yourself, what is the primary outcome? What were these authors looking for? What was the primary goal? What was the question that needed to be answered? They were looking for what? Clinical improvement within 28 days. Full stop. That was the primary goal. So whatever publishing data you're going to be seeing, because this article is filled with a whole lot of data, and you get tired from reading most of those, just perusing through them. But you must bear in mind that here, it's clinical improvement. Now, how did they define clinical improvement? Because clinical improvement in itself would have determined, you need points to determine them. So it tells you, in terms of objectivity, that is not, it tells you right away that this is not an objective assessment. It's neither a yes or no, or it is done or not done. Because 1, the clinical improvement was defined as a 2-point reduction in patient's admission status on a 6-point ordinal scale, which means even if 1-point parameter may have things that would define it, or a live discharge from hospital, whichever one came first. So I'm just going to minimize this and go back to that table. Let me project that table. Let's see if we can. Table 3. Oh, come on. Okay. Okay. Can we see table 3?
Yes.
Yep. Okay. So these are the results. Now, these are the scale they were trying to describe from 1 to 6. 1 being alive and discharged. 2, hospital admission not requiring supplemental oxygen. 3, hospital admission requiring supplemental oxygen. 4, admission requiring high flow nasal cannula or non-invasive mechanical ventilation. 5, requiring extracorporeal membrane oxygenation and invasive mechanical ventilation. And 6, death. So a patient would have been admitted at any of this point in time, depending on the day they were admitted. And if you're able to move, say, from 4 to 2, they consider that as clinical improvement. If you move from 5 to 3, then there's clinical improvement. But if you move from 5 to 4, it's still on the waiting list. So everybody they analyzed were people that jumped from one scale to the next above, okay? And then they have summarized the rates that at which this clinical improvement was occurring in both groups. So now we are managing COVID-19 patients, right? One we are giving remdesivir, okay, and the other one we are giving placebo. Please let me correct at this point in time. That's where the other problem was. I don't know why they have called this study a placebo trial. It is not a placebo trial. Let's correct that from scratch. Because a placebo will mean you are not giving anything. The disease is just following its natural course, or you are giving something else other than a drug. But it's clear from the table we had seen prior that they were giving other medications, even though they were in the control group. So it's supposed to be treatment versus standard treatment, okay? If they consider what the treatment group had to be what? Standard treatment, all right? And then they gave their rates of improvement in both groups. 3 here, 2 there, 4 there, and all of that. So we need to go through this and then decide for ourselves, was there a difference? Mark you, for each parameter you are looking at, even when you look at the difference in that single parameter, it does not really tell you whether or not it is better in the treatment group or it is worse in the control group, okay? So rate at day 7, day 14, day 28, which is the summary of all these things you have seen here, is that by day 7 in the treatment group, only 3% have jumped. In the control group, the same thing, 3% has improved. By day 14, 27% had improved here, 23% had improved there. So almost close. Now they gave the hazard ratio here, okay? Okay, they were looking at the rate of improvement or hazard ratio here. And they gave the mean with confidence intervals there. That we would explain shortly. 28th day, 65% increase versus 58% increase. 45, okay, 58 to 65. And then they gave this value here. This value here was, they've written it as differences. Now my first query was, this difference has to be in the percentages. If we're looking at those percentages, we're looking at whether this has the value of what? 0 in it. And if we're moving from a negative to a positive, you already see that there's a 0 in this confidence interval here on 28 days. There's a 0 in this confidence interval here on day 14. There's a 0 in this confidence interval here, even on day 7. So all of this we're seeing may well be occurring by what? Chance. So even though, yes, there's a difference here, there were no difference in terms of percentages, all of them could be chance finding and not necessarily important. So by the time I'm saying this, I'm not even going to be, will I still be thinking of using this drug if the drug is not actually proven? Well, that's it. But this table, the beauty about it is that it's huge. It has a lot of information that are not really useful to us, but they're there anyway, and we see these numbers and we can get confused by these numbers when we see that here is 65% improvement as compared to 58% improvement. We're almost forced to say, wow, at least let me tap into that improvement. But it may well have been the reverse. in this case. Now, this is looking at the table. Okay, the summary of the table is they gave us an adjusted hazard ratio, okay, for the stratification as 1.25 with a confidence interval of what? 0.88 to 1.78. Okay, what does this actually mean? 1.25, we're looking at improvement, which means it is a positive outcome. But yet we are using hazard ratio, which is okay. So what does it imply? We need to first think about it when we want to interpret this, because what they have stated is HR. If you look at the papers, you will find where it's written HR there, hazard ratio. In this case, greater than 1 would mean what? Clinical improvement. Okay? Even though we're using the term hazard, it means that you have a 25% chance more when you use remdesivir to get better. So your chances of getting better is increased by 25% as compared to what? The control group. Because if there were nothing, it would have been 1. Now, let's see, is that statistically significant? Don't forget, when we're dealing with hazard ratio, we're dealing with what? Division. The hazard ratio and risk, relative risk are similar, but not exactly the same thing. They are calculated in the same way, in the same manner. They are interpreted in almost the same way and the same manner. The basic difference about these two is that the hazard ratio is a projection over time, while the relative risk is, did the event occur at all at the end of the study? So hazard ratio can be at any point in time in the study, is over time. The relative risk is at the end of the study. What was the summary? That's the basic difference. So here we see that 25% chance of getting better has been displayed on the adjusted hazard ratio. However, it starts from 0.88 to 1.78 and still contains the value of what? 1. So which means it's not really statistically significant. It may just have been a chance finding. Now, how do we look at these results? There are so many of them there. How do we then see and compare both groups at the same time, eyeballing it straightforward? That's where we go to the Kaplan-Meier's curve or the survivor curve. The survivor curve, I don't know whether it comes out in the exams, but I'll just quickly deal with the survivor curve, then we'll look at the survivor curve, and then we can conclude whether or not we would use this study. So, a quick reminder, hazard ratio, HR, is a measure of an effect of an intervention on the outcome of interest over time. Please note that over time, okay? And you will see why it's so important when we begin to look at Kaplan-Meier's survivor curve, okay? The hazard ratio is reported commonly in a lot of papers, especially when it is a time to event analysis. Time you started the drug to when the patient dies, especially in those counter studies. Now, you ever wonder why people are able to say, oh, you have this cancer. The doctor says, no, this person have a 5-year to live. They are only giving you that 5 years because that's where the median survival is that has been reported in the studies for people who have that disease and have been managed according to the gold standard, okay? So the outcomes you are looking at can be what? Negative, or can be what? Positive outcome. Positive outcomes will include time to cure, time to discharge, time to conceive, time to heal, disease-free survival time. Adverse events would include deaths, of course, relapse, and time to treatment, okay? So how do we calculate the hazard ratio? Very quickly, hazard ratio can be calculated by dividing the hazard in the intervention group over the hazard in the what? The control group, okay? One of the main differences between the risk ratio, which we have discussed, and the hazard ratio is that risk ratio does not care about the timing of the event. It does not look at when it happens, whether it has day 5, day 2, day 3. It only tells you where the risk is. So if I was doing a study like Randomization, for example, and I start taking the drug day 1 and start getting better in day 5, I can't see it at the risk ratio. I can't say by day 5, 50% of the patients are already free of this risk. It's difficult, but with hazard ratio, you'll be able to calculate all of that, okay? In contrast, hazard ratio accounts not only for total number of events, but also for the timing of each of those events. How do I interpret hazard ratio? The same thing as your risk ratio. We'll go back to 1 again because it's division. Because we're dividing the hazard in the treatment group over the hazard in the control group, the point of no difference between the two groups is what? 1. Okay? So at any particular time, the rate events are the same in both groups, then the hazard ratio is what? 1. Okay? 0.5 at any particular time would mean half the people in the treatment group, is experiencing that outcome as compared to the control group. So if it is a hazard ratio of 0.5, it therefore means 5 people in the control group are improving, while 10 people are improving in the treatment arm. If it is a negative finding, it means 10 people are dying in the control and 5 are dying in the treatment arm. So you need to always bear in mind how you interchange that when you are interpreting a positive or a negative. Okay, if the hazard ratio is 2 at any particular point in time, it means that you have twice the patient in the treatment group experiencing the event. Okay, so hazard ratio for death. Let's just look at a simplest way of explaining and breaking it down, and then look at the Kaplan-Meier's graph and what it actually states before we then go and look at the one in the study. Okay. Let's take, for example, a hypothetical study that looks at the hazard ratio for death with a new treatment as 0.38 at 95% confidence interval of 0.28 to 0.53, p-value 0.001. We would agree that just looking at the p-value, we say statistically significant. We look at the confidence interval, it does not include 0. Okay, from 0.2 is already bigger to 0.35. So we say this is statistically significant, right? Okay, so if we agree that this is statistically significant, how do we then interpret this? Now, because we are dealing with death, 38 is a fraction. If I subtract this from 1, what I'm going to have left is 62. Okay, so the risk reduction from death is what? 62%. So it's likely that 62% are less likely to die from this treatment group. That's how I would interpret it. Okay? And 95% confidence interval, and we're 95% confidence, if we look at the confidence interval, that protection, if we now start using it generally for all the patients, it's going to fall between 47% protection to 72% protection. That's what the confidence interval would mean, okay? All right, for further description and analysis or interpretation of hazard ratio, risk ratio, you can consult students for best evidence, or you can, even in evidence-based medicine, there's also an interpretation there. So when we have something like this, you're not going to plot a graph from table 3 that we've just seen. All of that event can be plotted on the Kaplan-Meier's curve graph, which is something like this. I don't know whether you can see it clearly. Okay. Now, what does this graph, what does it say? Firstly, we need to realize, first and foremost, what you want to identify is which is the treatment arm and which is the control arm. This is still for the hypothetical study I've just given. This is not what the authors have printed. This is just for explanation. So the blue, treatment. The green here is the control arm. Okay? So we're looking at, here they're looking at hazard ratio for death. Okay? They start the drug in the treatment group and they didn't give it to those in the control group. And then they now plot the graph. First thing we have to recognize here is that you see this graph is not a smooth line graph, okay? If you look at it, it has like steps coming down, okay? All the steps you would see, the steps, it keeps dropping. And then on each of those line graph, either on the control or treatment arm, you see some bars crossing, okay? For every step you see is an event occurring for a single individual in the study. If the step becomes long, a huge leap down, like the one you find here from, let's say from here down there, it means that there are many more people who are experiencing that event in this case. What are the axes? On the vertical axis, you have what? Survival percentage, okay? On the horizontal axis, you have the time or survivor days. This time is in days. So if we assume that this new treatment was for cancer, and people started taking this drug by day 0, by then day 2,000, day 4,000, day 6,000, you know, they were analyzed. They now plot the survivor curve, okay? What can I get from my survivor curve? Firstly, take note of this blue line that says, or let's start from the red dotted lines here. If we now say, okay, we've recruited 100 people in the treatment arm, 100 people in the control arm, right? At what point in time of the study, I keep following them up, first year, second year, by the third year, how many people have died? When 50% of the people have died, that's 50% survival, and 50% left in the group. You can actually trace that to your curve and draw it down and see how long it took 50% to die. So the survival rate, 50% survival rate in this group will now be how many days? You can actually pencil that down to say this. Mean survival time of 50% can now come down to 2,246 days for the treatment group. But that same 50% for the control group comes down to what? 960. Okay? So the median survival point of 50% is a good way of looking at whether or not a treatment is effective doing what it's actually supposed to do. Because the median survival time should get better if the treatment is supposed to prevent death. Or would mean that many more people have been discharged over time if the treatment was supposed to what? Maintain health or deliver cure to that ill disease, okay? So a mean difference can also be looked at, okay? Where we subtract the mean survival points from treatment group minus mean survival points in the control group, that gives us the mean difference. That's another way of looking at it. And if the wider your mean difference, the more effective your drug is, okay? Either to cause the cure, what we're talking about. Then the other is to look at time. I can say, okay, how many people have survived by 4 years? So I'll do a calculation of how many days are in 4 years or in 10 years. In this case, they were looking at 10 years here, which is about 3,650 days. And then in 10 years, they draw a vertical line up, and then you see about 45% have survived to 10 years. So if I'm now applying this to my patient and they say, okay, I have this cancer now, hey, will I survive? If you take this drug, well, you have a 45% chance of surviving the next 10 years. okay? And you have a 50% chance of surviving the next 2,246 days, which approximates to almost, how many years? No, close to about 7 years, 6 to 7 years, okay? And that's how they arrive at that. That's why the survival curve graph is so interesting. Now, another thing it looks at is the exposure, the proportion, the exposure or the risk of exposure over time. Does it get better, or does it get worse, or does it stay static? Okay? Okay? So the graph would also tell you, you know, whether or not there is a sudden event like death, dropout, discharge from hospital. All of these are represented in the bars that crosses your survival line. So if they ask in the exam what some of these things actually mean, the step, vertical step, means an event is occurring for one single individual. If it's longer, it means a group of individuals are experiencing the event at the same time. If you have a cross on that line, it means a defined event is occurring at any point in time, discharge, death, or whatever. Okay? Okay, this I've already explained is the interpretation. So now, the other thing we'll notice with this graph is you see how wide this is becoming. They started almost at the same point, and soon they begin to what? Diverge to their different directions. That shows the efficacy. If nothing is happening, what would you expect this graph to do? They will keep following each other. They keep following each other down the same line because nothing is really happening. That's another way of eyeballing the Kaplan-Meier curve. So now let's take a look at the the graph that was published. We're almost there. Okay. Where's our Kaplan-Meier? Okay.
7. 8, 7.
Yes. Okay. So this is the graph we've seen. What's the first thing we'll notice about this? Okay, Remdesivir is the red, control group is blue. What's the first thing we'll notice? You see the graph is going up because we're not dealing with a negative adverse event, we're dealing with a positive adverse event. So it's climbing up to discharge, okay, over days. And what is represented here is what? Cumulative improvement rate. So we're looking at the improvement. 0.1 being least improved, 1 being most improved. And we're looking at it over time, okay? Number of study days. The first thing that you would notice here is that this graph is just kind of following each other, okay? They're very close. The blue and the red are just going in the same direction, parts like that. So one, they're quite close. Hazard ratio that was given here, we've already analyzed that already. And then number at risk or number censored is what is given on this table, okay? Over time. So over time, the number at risk or the number that are likely to improve in this case will be what's left after somebody has died or after there has been an improvement or a jump in the improvement. Okay, so here you can see the reduction as it's going, and the same thing with the control group. Okay, and the mean being 1 or 2, 1 or 2, 1 or 2. So the recovery rates, the average recovery rate by the first 4 days were 2. But it stands to reason in the Remdesivir group because we met them at day 10. So they are bound to recover more quickly because they're almost hitting day 14 as compared to this group. That's why you can also find 0, 0, 0, 0 here on the average. Okay, but all this would be statistically imputed and read off. So if I look at the Kaplan-Meier curve here, I won't say that there's any significant difference between both because the graphs are close together. The hazard ratio here is the space you find in between, yes, but it is not statistically significant. Okay, so how do we conclude? With what we've said so far, is there sufficient evidence in this paper to show benefits of remdesivir? And will you use it? That's the question. I'm not going to draw any answer here. I'm just going to allow the moderator go ahead and find out from each and every one of us that have been listening whether or not they would use based on what we have analyzed so far. And for the references that you may want to look at later, there they are. And thank you.
Thank you, Tony. Dr. Kabambi is the moderator.
Hi, Prof.
Hi, Dr. Kabambi.
Thanks for the late appointment as a moderator.
And you are a real one, not a fake one.
But these days, it's difficult to differentiate between the real and the fake. It's become quite blurred.
Especially when it comes to COVID. Ne?
You see? Okay. Really, thank you, Dr. Usenbo, for this heavy loaded tutorial. Really, you are such a blessing for all of us in the department. I want you to really know that what you're doing is really much appreciated, and we really like that. So I don't want to make too much comment, and then I'll give the floor for all who are here to have a comment, to have a time to say. So if you want to talk, and you tell me who those who are in the room who want to talk, but the others just go into your Zoom, raise hand, I will acknowledge you. Okay. Anyone?
Okay, I can start by saying, I think working with Dr. Usenbo through this paper, we saw that you can't draw any conclusions. Number one, I think you showed that the comparison is inappropriate. It's not supposed to be placebo because there are other treatments, so which confounds the whole result. And from the curves that you showed, especially the last curve, there's no difference shown between the two treatments. And in any case, the sample size calculation was not appropriate, as well as the fact that the two groups were unbalanced. So we really can't say. So, but for me, I wonder if we cannot definitely say that, because the way they conducted the study, it looks like they set out to prove that the treatment works. So despite the fact that it was inappropriately set up, they still could not prove that the treatment works, which shows that you really have to doubt that it works, because they were favoring it in many ways in how they conducted the study.
Yes, I quite agree, Prof.
But then it goes back to the question of how the Americans...
I will try my best to play the devil advocate. Prof, you can go ahead.
Yes, I'm saying I wonder about the American paper then that says the treatment works.
Okay. Has anyone seen the paper? Because I haven't seen the paper yet.
I haven't seen that paper too. It would have been interesting to put this side by side.
Yes.
Yeah.
So maybe we can do it next time on Monday, like half the presentation.
Okay.
We just go through with the same principles using your template.
Okay.
Okay. But first we need to prove that it has been published, because it was just an announcement.
You think it's a fake paper?
No, it was just an announcement, and then the paper is not yet went to the to print. Yeah.
Okay.
So it may still not be available by Monday. That's what I mean.
True.
Okay.
Yeah.
Yes, devil's advocate.
Yes. Okay. When Prof says that, given the negative finding of this trial here, we should be more on the side to say it's not working.
Hmm.
But given that the power is just been very low, up to 58,
Yeah.
isn't it possible that we are dealing with a false negative study here, given the lower power of the study? Then we should be cautious to jump into conclusion to say it's not working.
Okay. It's interesting, but the problem with that as well is that the sample size and the ratio of recruitment even makes it further difficult to draw a conclusion. Don't forget, they discontinued in 18 persons, or they discontinued the trial before the end of time for the reason that, one, they had an epidemiological arrest of the infection spread in Wuhan, so they discontinued. It was the fact that the adverse event rates that were reported in the treatment group was becoming more. So the control, the trial control decided to end the study, which means that they have not even, it would have been nice to actually see the protocol, because the other thing they didn't do here was to state for us what they had in the protocol as the number of patients that would be recruited on the ratio 2:1 that would give sufficient power of 80% at the least. Then we can now begin to compare, but they only give us, after their recalculation, that it had dropped from 80 to 55%. So we would expect that that size, the number that was projected was almost twice what they will be recruiting. So it's difficult to draw whether it's a negative finding or whether it's a chance finding. That's what makes it very difficult. In as much as we can say that there are methodological flaws that will not allow us to accept the result, those methodological flaws are also there and will not allow us to conclude that it is a negative finding.
Okay, so you will agree with me that we should be more prudent and to jump it's not working. So we still have room to prove if it's working.
Oh yes, there's absolutely.
Okay, on my second advocacy for this year, I'm playing the devil advocate anyway, so don't kill me because I'm playing the devil advocate. Eh? You say that you did not believe that they used the intention to treat analysis.
Yes.
I don't have the paper with me here, but when I was perusing, when you were showing there,
yes,
on the table 3.
Okay, let's go to the table.
Yeah.
Table 3.
Yes.
The table says outcome in the intention to treat population.
Yes.
Yes.
But the number on the remdesivir group was 158.
Yes.
Yeah, and the number on the placebo 48
was 78.
If you go back to the graph.
Yes. Which of the graph?
Yeah, this one.
Okay.
Yeah, you'll see this with the assignment. Okay, 158 and 158 and 78. Those were the intention to group population.
Yes.
So with this, they analyzed the patient according to the intention to treat analysis. Would you disagree with me with that?
Okay. let's see.
Yeah, because my understanding is just they gave us the different scenarios. If we do the intention to treat analysis, we should get 158 and 78. But if we do per protocol analysis, we would get 150 over 76. But on the table 3, they used 158 over 78, which is the intention to treat analysis.
Okay. Now, okay. So I'm projecting.
Yeah.
I'm projecting the beginning of the results. Under results section, this is why I said there's still something there. You see this number here? That's 79, not 78. And this is post-randomization. Okay? Patients
78.
Patients were screened, 237 eligible, 158 were assigned to receive remdesivir, and 79 to receive placebo. Where is the one? The one refused consent, and they removed from the analysis. But the patient has been randomized already. So for intention to treat analysis, whether or not you still get that, you should be analyzed under that section. So your numbers will become different. And when you are dealing with a factorial, 2:1 already, which means that you're already on a deficit. And then you are now reducing that further. That changes your ratio to start with above. And again, statistically, it will influence every other thing. Now, whether that is, whether the fragility index here, because what I did not do was to calculate the fragility index. It will be interesting to know what the fragility index would be from reducing 79 to 78. If we were to apply it in that sense, I know it's not the outcome, it's the number of people here. Will the outcomes change? But they've randomized 79 and they have analyzed 78, and the analysis has not included one person, which was already in the disadvantaged group in the first place. And that's why I said, that's why I gave it a no. So in the paper, some of these things can happen. You can see the table, everything, then soon they just put this here, 79. They did explain that the patient withdrew consent. And then you don't add it. So that's not intention to treat analysis.
Okay.
Now you have violated the intention to treat analysis by doing that. And that's the reason I gave a no. But
that's
again,
why one only symbol. What are you so harsh?
One is a violation. We're not looking at the numbers. Don't forget, we're not looking at the numbers. We're looking at the violation for the intention to treat and how it can influence. And I told you already that if you look at a paper by let me see if I can. It's by Maynard. I don't know whether that's clear, no? Maynard Clinical Trial Design and Conduct and Analysis. It was published in 1986 on equal allocation. Her conclusion then in that publication and article is what I was trying to. Okay, let me see. Okay, unequal allocation has consequences for statistical power. For example, a 2:1 allocation ratio requires 12% more patients than a trial using 1:1 to detect the same size effects with equivalent power. You see, and a 3:1 ratio randomization scheme will require 33% more patients. Okay, and it was published in this study, and people still hold dearly to that, and that's why people will try as much as possible to remain on a 1:1, so you don't alter that power. So if the power is already skewed and you haven't reached the desired number, and it is further reduced by attrition, even though it's less than 20%, then you are already in trouble. It becomes more significant. If it was a 1:1 ratio, then that one person would not have mattered so much. Okay, but because it's a 2:1 ratio allocation, then it becomes significant. So you need to work out, the statistician needs to impute that to see the effect of losing that one patient before you can conclusively say something. So it either would remain unclear or a no, but for me, I'll decide a no.
Bad. Anyone want to comment? I've been defeated.
I
Lovo?
just want to ask a question. In the
Yes.
methodology, there was something about the participants. First of all, they start by saying there are people over 18 years. But then when you look at the sample, these are elderly patients, middle-aged and elderly people.
Yes.
So I don't know when you're writing a protocol, is that correct? And then the second question is about some of the people were consented for using oral contraceptives, which I did not understand. Like, it's like a red herring in the paper. Like, what has COVID-19 got to do with contraceptives if pregnant patients were excluded? And then the other thing is, we know oral contraceptives are procoagulant, and now we know that this disease causes coagulation. So are you not already killing the patient by saying, come into the study and start taking oral contraceptives? So I don't know, I just thought that was something, maybe you can comment.
Okay, as for the second part of the question, I would allow the House to comment, because I also noticed that I was going to check effect of oral contraceptive on remdesivir or its drug interaction. It was not stated why they did that in the paper, but I was going to check whether or not it had a serious drug-drug interaction problem, or whether or not they didn't want to include people, they didn't want people getting pregnant during the course of the 14 days, which is quite short anyway. But I would want to think it's more or less on the drug-drug interaction basis. I don't have that evidence. I haven't checked it up. So if anyone does, then you can let us know. As regards the cutoff being 18, when you're dealing with adults, you're dealing with adults. You don't know the patients you are going to be recruiting and how they come. Okay? So you are still right by saying 18 years and above. And irrespective of what you get, is what you get, because you are not determining who gets sick and who comes. So if it is many more people, then that's fine. The only thing that you need to do is now in your analysis to stratify the ages and see whether or not it's an age-related disease or phenomenon. In fact, it's because of the type of people who have been included in all the studies that we begin to see that elderly is a risk factor, because if you do a multivariate analysis or a regression analysis on the baseline characteristics, you will find out that the outcome may well be associated or related with age.
Okay.
Dr. Kawambi?
Okay. Yes.
I don't know that part, the oral contraceptives. I don't know if anybody has anything on that.
No, I still have to go through the paper thoroughly. Maybe next time we will, Monday, I can come with the comments. I haven't really gone through it. Okay. Anyone else? Want to make a...
Sabona has raised hand.
Yes.
Yes,
Sabona?
morning, everyone. Morning.
Morning. Morning.
Yeah, my hand has been up.
Seriously?
Yeah. So the question to us was, can we use remdesivir for our patient? And after having read the paper, I cannot decide. So the paper is not conclusive whether or not this one that I read, because they have a power of 58%. We need a power of 80%. And from the biostat course that I was attending, they said that a study that is under or overpowered, it is unethical. So it bothers me that this paper was even published, was accepted by the ethics committee, and it was published. Because the power is the one that is going to tell us, to help us to find the clinical important difference. So now if the power is 58%, how are we going to say that there is a difference between the patient, even from their primary outcome, which was a clinical improvement, they could not find it, but because that the study does not have internal validity, so it's difficult to draw any conclusion with that. So the other thing was, on their discussion, they were comparing this study with the one that was done for the compassionate use of remdesivir, and then they said that they started the treatment early, which is 10 days later. I could not really understand that. For my understanding would be if you are giving an antiviral, you should start it during your viral phase of the clinical course, because the remdesivir is not an interleukin-6 inhibitor where you can give it in the hyperinflammatory phase. So also that was a problem for me. So yeah, and also yeah, so when they did identify what would be the clinical improvement, and then they did the PCR for the patient, but now on the follow-up day 28 mortality, they are saying there is no, yeah, as far as the clinical as far as the 95% confidence interval, there is no difference in that. In mortality, there is no difference in the duration of the treatment, which was their secondary outcome. And even on the clinical improvement, there was no difference. But also they did not report on the PCR if this patient, they have a PCR negative afterwards or not. But overall, I would say I can conclude.
Thank you, Dr. Sabona, for your comments. It was really worth, you were to the point on many issues that you raised.
The paper.
Yeah.
Sorry?
It shows that she has read the paper.
Yeah.
She read again, she read again. I said, I will impress them that day.
Very well done. But the thing is that, Sabona, you can draw the basic conclusion. If the paper lacks internal validity, then it can never be generalizable, which means you can never apply it to your patient. So by following the rule of thumb, internal validity before external validity. If the internal validity, if it does not pass internal validity, it therefore means that the findings there cannot be applied to you. If you are going to apply, then you must use with caution, and you must do not because of the study, but because you want to try a trial of your own. But you will not be justified, ethically to give it to a patient based on all of these flaws that have been mentioned.
Yeah.
Okay. So far, remdesivir is not helping us so far.
No.
The evidence that we've heard. So we need now to see the American study and find out what did they find different.
Yes, so we need to look at the American study. I think it's high time we begin to look at the Madagascar study if they are able to publish.
On the COVID organic.
Yes, on the COVID organic, because all these ones are failing us now.
So we need to go to African medicine now.
And then let us watch out, because if we are going to start a vaccine and the vaccine trial starts, the reason I actually went ahead to explain the Kaplan-Meier's curve is that most of the data is going to be published using Kaplan-Meier's, because they are going to be showing the hazard of using that vaccine. That's the most important concept. It's a vaccine. It's not supposed to cause harm. It's supposed to be preventive, stimulate your immune system. But the biggest profile they are going to be looking at, which has not been tried out, is how hazardous is it. So hazard ratios and hazard Kaplan-Meier's graph is what you are going to be seeing in a whole lot of studies that are going to be coming up should they go into the vaccine production. So we must all familiarize ourselves with them and get conversant to interpreting them. Go to the references I have given earlier. Please go through and get more clarity. I know half of the people probably will have been sleeping by now. That is research for you. I'm glad the people seated with me here have been fantastic audience. So thank you for listening.
Okay, thank you very much. I recall that some people had to give us update today, but first was Liwani, who need to give us updates on something today, but they've been quiet because of the time issue as well. So just we keep them for Monday,
Yeah.
so that we get update from everybody who are supposed to give update.
Dr. Ninise has a question.
Ninise.
Yes.
Oh, thank you, Dr. Usenbo, for the wonderful presentation, and it brought insight into praising and critiquing a paper. So I wanted to know, when you're talking about internal validity and external validity, so when it comes to sample size calculation, what part of which part does it fall under? So internal validity or external validity? When your sample size is not enough for you to pick an effect.
Okay, it falls under internal validity. I'll clarify that again. Internal validity is everything you as the researcher has done to ensure that the conclusion you are going to draw is free of bias, or the bias is brought to the barest minimum. There are some bias that are not just, that are unavoidable, that you cannot just avoid. So you want to minimize them, okay? So everything you do, and it starts from the question you are asking, okay? Does it have the component part of that study design you need? Because if you have a question, it is your question that determines the method to answering that question. So your methodology has a huge bearing on the question or the clinical issue you intend to answer. So if we're looking at randomized controlled trials, the clinical issue must border around a group of people. It should border around a possible intervention or a group of people with a disease. It should border around a possible intervention for that disease. Then what are you comparing it with to see that that intervention is actually working, which is your comparison? And then what outcomes are you looking at? Those four are key. They are very important. So if you have that, you can say, okay, we may be able to answer this question because I know what I'm looking for at the end point and I know how I'm going to look for it. So everything that you now do in your study design and study implementation is what defines your internal validity. So in the protocol, for example, these people now would have written a protocol to say, we're going to do a double-blinded, placebo, multi-centered, randomized controlled trials. And they may have thought that they were just going to give water or whatever to the patient, their drip. But they did not consider the fact that a patient who is sick cannot just be left alone because it is unethical. Only they do that. So their study should have been modified to treatment versus standard. So the comparison can be treatment, can be standard, or can be placebo. In fact, in modern day time, just note that only very few placebo studies are allowed in modern day times because ethics will not approve it. It won't say true most ethics. So once you see a publication with placebo, be very cautious. Unless it has nothing to do with a process that leads to a negative event. Because if it's leading to a negative event, not doing anything can become unethical. So that's the first goal. So then if you now written out your protocol, how you now implement the protocol, do you actually do what you say you were going to do? Authors may have even done them, but if they fail to report them in their methodology, it is assumed that they haven't been done. So if I'm reading it, I get confused. If you have not written it, I will assume you haven't done it. But if I was doing a systematic review and I see you have not written it, the next thing I'll do is to write to you to say, this is not done. Can I have a copy of your protocol? Or was it done, to verify before I can draw that conclusion? Okay? So your internal validity is your study design. Is it appropriate? Does it meet the right population? Does it have a defined outcome? Are those outcomes objective or subjective? Can you measure them? Did you take the necessary precaution to minimize bias or to remove bias? Okay? Then all of that encompasses what is known as your internal validity. Okay, and that's what we appraise in critical appraisal step 3. Then, whether or not, at the end of step 3, what should you draw? 1, you must decide whether or not the paper is good enough and has sufficient information to confirm that conclusion that has been made, that remdesivir is good for COVID. Have they done everything right to draw that conclusion? If they have, what are the conclusions? What are the interpretation of the results? Are those results meaningful? Before you can now start thinking of externally validating it, whether or not it applies to me, which is now your external validity. Okay? And all you are thinking about in the external validity is that, oh, this paper is very good, this drug works well. Can I give it to patient A if I see him in clinic tomorrow? And things I look out for to do that is to look at, is my patient A similar to the patients in that studies? If it is, I tick the box. Is the treatment available in my center and is it feasible? I tick the box. Is my patient so different that I cannot use it? If so, what are those differences? Can I mitigate them? Okay. Then what is the potential benefit of me using this drug as compared to the harm? So at the end of external validity, you want to do a risk-benefit analysis to see whether or not it is worth using. That's what your external validity is all about.
Okay, thank you.